Alright everyone, in this video we're going to be talking about cones. So this week we're going to find the volume and surface area of cones. So first, to find the volume of a cone, let's think of what the basic formula would be. The volume is 1/3 times the area of your base times height. So here for a cone, I'm going to think about what is my base. My base here is a circle, so I can change the area of the base to just pi r squared. So now I have 1/3 pi r squared times height. Last thing to pay attention to here is that my height has to be perpendicular to my base. So my height is going to be from the tip of that cone to the center of that circle, and it's going to meet at a right angle. So that's going to be my height there. For the surface area of a cone, my surface area formula is going to go like this: pi rs plus pi r squared. So pi r squared comes from the area of your base. Pi rs comes from the area around everything else in that cone. But what does the s represent? So while my height represents up and down perpendicular to my base, s is my slant height, and that is going to be that measurement there. So the actual kind of side length of that cone. So in the first example problem, a cone has a radius of 7 centimeters and a height of 24 centimeters. I want to find the volume and the surface area. So again, first let's start with my volume. My volume is 1/3 pi r squared times h. I'm plugging in, just kind of drawing the stuff that I know. For my volume, I need the radius and I need the height, and they're both given to me. So all I have to do here is plug stuff in. So 7 squared is going to go in for my radius squared. That turns into 49. 24 is my height. When I multiply that all out, I end up getting 1,231.5 centimeters cubed. Moving on to surface area, I see that I have my radius, but I'm going to need to solve to figure out my slant height. So what I'm going to do here is look at that cone, and I can see here that I have a right triangle formed, and my slant height is my hypotenuse. So I'm going to make a right triangle. I have 7, 24. If you know your Pythagorean triples, you know what the hypotenuse is. If we're stuck here, I'm going to do the Pythagorean theorem to solve. So 7 squared plus 24 squared equals x squared. Again, because that x is my hypotenuse, that's going to go by itself. When I solve, I get 25. So when I plug all that stuff in, I do pi times 7 times 25 plus pi times 7 squared, and I end up getting 703.72 centimeters squared. In the next example, I'm going to be given the diameter and the slant height. So a cone has a diameter of 12 inches and a slant height of 10 inches. Again, I want to find the volume and surface area. So let's start out with the volume. So they gave me a diameter of 12. So I need the radius to plug into my formula. So if that diameter is 12, cut that in half, my radius is 6. From there, they gave me my slant height of 10. So again here, I need the perpendicular up and down height. So I'm going to set up a right triangle, use the Pythagorean theorem, and solve for my missing value. So here, since I have a missing leg, I'm going to set it up like this. X squared plus 6 squared equals 10 squared. I'm going to square both of those. Minus 36. I have x squared equals 64. Square root both sides. And my missing value, x equals 8 here. So my height is 8. So I'm going to plug in those values as I know them. 1/3 times pi times 36 times 8. When I plug all that stuff in, I get 301.59 inches cubed. So now, let's plug in to find surface area. So I'm just going to leave my diagram up, which is kind of nice once you get to this point, is I have my radius, I have my height, and I have my slant height. So I have all of my information that I would need to find volume or surface area. So here, I need my radius and surface area. So I'm going to plug those in. And when I put those all together, I get, coincidentally, the same thing. 301.59 inches squared. Keep in mind, this is kind of random how it worked out, but the volume and surface area are two different measurements. Again, think of volume as like filling something up. So here, like I'm filling up an ice cream cone. Surface area is I'm wrapping that cone. Okay, so two totally different measurements.